Okay, I'm starting a little bit earlier and I've got some vocals, so looks like we're recording and away we go. Today is Wednesday the 11th, and of course I sent my schedule out to everybody today, and as usual I'm doing a screencast, a remote screencast from office here in Oklahoma City, and I'm a little bit early, so I'm sure I'll have some people join me. Now, I wanted to talk for just a few moments about where we are in the course, the usual thing of what's going on. Today, of course, is the 11th, and we're going to take a look at single arbitrary. That was a case that was due, okay, and we'll talk about that. I have the key here, and then we're going to talk about Hammond's Port 1, which is due on the 13th. You also have an exam that's coming due on the 13th. That's chapter 11, okay? And in addition to that, I want to take us through the remainder of the course just to kind of keep us surprised as to what's happening. Now, I'm seeing that, I've got myself at this point. I'm hoping I'll have a few people join me. I assumed him. And of course, because it's remote, or even when I'm over there at the BBC in the library, you can be there or not. It's up to you. I do want to let you know I can track your participation. I can see everything you've done or not done. And so if you're not participating, I can assure you I'll see it. And it will probably show up in your grade. That all being said, you're adults. I'll treat you like adults. The tasks that you have ahead of you. And so it's up to you to do what you need to do. Now, I want to talk for a moment about where we are. And today we're gonna finish the outliers, which is chapter 9 in the Data Smart text. So we're going to finish it today. All right. And we're going to take a quick look at Hammond's Port 1, and then we'll move on. So I will probably run over 50 minutes, which is fine. And if you have to pop in and pop out, that's fine, no problem whatsoever. All right. Now today, as I said before, we're going to review single arbitrary. I've got a key there for you. Okay, and then a recording to a Zoom recording link. Then I also have a couple of documents, Support Center 1 and Support Center 2. These two documents, okay, provide us some help or assistance as we go through that outlier, as we go through the outliers case there over in chapter 9 in the Data Smart text. Okay, and then we have a resource there about looking at the probability that we would obtain a z-score. Okay, and that's what that tool is designed to do. And of course, a z-score is a way we normalize scores, and we're able to compare observations of apples and oranges. Nonetheless, then also we have a chapter 11 due. Okay, that's due on the 13th. Now, I want to move on through. I have some resources here for you, and talking about simulation. And when we start to move into Hammond's Port, and we'll go over to the book for just a moment, okay, we're going to be talking about, and Hammond's Port, that case deals with the creating simulation models, okay? And so we're going to be moving into a point where we're looking at simulating events using tools that randomize observations or numbers or counts or whatever you would want to call it. Now, as we move through here, also I have a resource on how long will customers wait for service. So this is part of, again, one of these things that we're dealing with in management science, and we use queuing theory, right? Waiting time. And so then that becomes a way that we build a mathematical model. We could even build a schematic or iconic model with a flow chart, and then try to use the thing out in the real world and evaluate and see how well it works. Okay. Now, in module 11, all right, that's going to be next week. That'll be the week of the 16th, the 18th, and the 20th. Okay. And basically, we'll look at Hammondsport 1. We'll talk about it. Okay. And I'll have a screenshot and a video for you. And then Hammondsport 2, case number 2, will be due on the 20th. And an exam on chapter 12 will be due on the 20th. All right. And I also have for you several resources. Little's Law, that talks, and that's the basis for queuing theory, its applications. And I have a resource of Little's Law as applied to an emergency room. Here's reducing waiting and work in progress time at a frozen food manufacturer. Starbucks, basic waiting line models, and a lot of resources, including a resource on the norm distribution function in Excel and the norm inverse function in Excel, and how and why we use them. Okay, and how that's used in Hammondsport 2. Okay, so that's next week, which would be the 16th, the 18th, and the 20th. Now, as we flow on down here, we come back to the week module 12, where we have the 23rd, the 25th, and the 27th. And this week begins flex time. Okay? I will have those keys and screenshots available for you. I have a PowerPoint on chapter 13 because we're going to be dealing with one of the cases there you have is the tree plan, and an example of that, and it will explain all that. And I have several resources here for you as regards projections. And one of the cases you'll be working on will be the PDC project, and then exams in chapter 13, 14, and 15. And then I have some instructions for you on the SAP Business 1. So there won't be any lecture time. That's flex time for you to work through all this stuff. Okay, so I'll have things posted for you. All right. And relevant cash flows. So that's the first flex time week. That's module 12. And I may just come on and do a short screencast and explain what you ought to be going, what you should be doing. But you're all seniors and juniors. You know what you need to do here. I also have instructions for the Anderson text. Okay. And that's for a self-developed quiz from the Anderson text, and I have the instructions for you, the resources for that. Then we'll come to module 13. Again, you've got flex time, okay, and you have the AHP the AHP case. Okay, and then on module 14, you have the SAS Business 1 Part A, SAS Business 1 Part B. The Anderson text self-developed quiz is due, and that moves us into the final exam. So you'll have had those times to work on your exam. So starting week 12, okay, we'll be moving into flex time. So I'm going to be doing some short screencasts, okay? And if you show, fine. If you don't, you don't. But they'll be very short. And usually just to say, here's the key, here's the response, etc. But I do caution you and urge you to understand something. You've got 3 exams coming up next week. You have this project using SAP Business 1, and you'll also have the Anderson text. That's the big one, a self-developed quiz, and I'll talk about those. And then we move into the finals. So we're moving rapidly through the semester. Okay. Now, at this point, it's 11:07. I'm noticing I don't have anybody here. And that's fine because I'm doing a live remote screencast. If you chose not to do that and you look at it at a later date, that's up to you. All right. I've built maximum flexibility into the course to the extent possible. All right. And just as I am forgiving of you when you have sporting events or tournaments or this or that, I've had some medical things to take care of myself and also with some relatives. So I've had to I've had a bit of a crazy schedule. So I'm not going to complain. You know what you need to do, you know the things you need to take care of, and we'll go from there. All right. But this doesn't mean you don't have anything to do. You have 2 major projects, and you need to be getting ready for the final. Now, I want to say this. The final has a Part A, which has a Part A, Part A1 and A2. Then you have Final Exam Part B. Final Exam Part A is due at the start of the final exam period. Part B is due at the end of the final exam period. Okay, so if you're smart, you will start working on those projects, get them done, and then get started on your final, because the 14th of that week of finals will come much faster than than you anticipate. Okay, and because this is a senior junior level course, I'm assuming that you've understood about having some initiative, being self-directed, and so forth. So that's something that I just have to believe that you have internalized that. So you view these videos and you have an idea of what's going on. So the first thing I want to do is I want to talk about Hammond's port. And we'll do a review of it and then just a quick preview of it. Okay, so here's the key for Hammond's Port 1, and I'm going to make it available for you. I'm going to publish it because it was already due, and we'll take a look at it. Now, again, if you go over into the book, and we see customer arrival times, and actually what the textbook talks about arrival times and a waiting time simulation. Okay, and so I'll go back over here. Here's Hammond's port. I'm going to download it so we can see it. And we'll talk about what we were asked to do in Hammond's port. All right. Now, we were asked to use goal-seek to obtain a probability of weighting to 0.55. Okay, so we have the probability of weighting of having to wait, and here's the probability. We're going to use goal-seek by changing the largest value for inter-arrival times. Okay, and we were to use goal-seek to do that, and a maximum waiting time to 9.5. So we'll find the maximum waiting time over here. And we're asked to use goal-seek to obtain that maximum waiting time to 9.5 by changing the mean service time. So let's first of all, okay, do the very first one. And we'll look here. We're going to click on data. Okay. And then we're going to go to the solver. All right. By some screen size here, just a second. I'll move this over here. You can't see it, but I'll do the solver, and we're going to use the goal seek to obtain a probability of waiting time. So I'm going to make myself a quick note here. Okay. And we can go in and we can go into the solver and take a look. A probability of waiting to 0.55 and the largest value, enter arrival. Okay, so I'm going to click, I'm going to need to do solver. I'm going to click goal seek, what if analysis. Okay, and I'm going to set the cell, and I'm going to find the probability of waiting time. Okay, I want the probability of waiting time right here, pardon me. Okay, and we're going to change that to 0.55 by changing the cell. And we're going to go back up here let's see here. I want E109, and we'll go back up to the largest interval that we go up here, and that's going to be the largest, that would be cell B5. Okay, so we'll go down here just a second, and we'll click what if analysis, and we'll do goal seek, and we'll set the cell here for the probability of waiting. All right, and now we've done we've simulated this 1,000 times. Then they take you down to the 5th customer, and then they hide the rest till they get to 1,000. So don't let that throw you. And we're going to go 1,019, and we're going to set that to 0.55, and we'll do that by changing cell B5. And we'll click OK. And there we are. We got the solution. And the largest, we've got 55, so I'll click OK. Let's scroll up there and let's see. Now the largest value, and I have a screenshot there for you, I think, that shows each of those. And the largest value is 5.288. And that's the largest value for enter arrival times. And then the goal seek, we set that at 0.55. Now, before we go too far from this, I want to take a look over here for a moment in the text, and let's talk about it. They give us waiting line simulation, and Hammondsport's dealing with that issue. Okay, it's dealing with simulation of waiting line. And so they walk us through a dynamic simulation model, discrete events, okay, not continuous events, but discrete events. And we see their waiting line. And we see the enter arrival time and how it's computed. And we're given those figures, and we're shown the enter arrival time. And the authors give us a little caveat here about the shape of the distribution. And here's a normal probability distribution of service times. And we have a service time of 2 minutes, and here's an example, a standard deviation of a half minute. So somewhere between 2.5 minutes and 1.5 minutes, we would have 68% of the arrivals. Then we see the simulation model, and this is important for you to understand. Here we're talking about this savings bank. These are the number of ATMs. Okay, this is an iconic model of the mathematical model that we'll use with the solver. And here we see the number of ATMs, the inter-arrival time, the service time, and then the operating characteristics. And you can see these are some in the textbook going right through this. Then we see the flow chart. Okay, and again, this is in management science where we're building an iconic model, if you will, a flow chart of that process. And then the text gives us some more information on how that results. And then it gives us simulation results for 10 customers. Okay? And they walk us through one customer, there's two, there's three, how that chart's put together, that table. And they show us the Excel worksheet, which we had, and histograms showing the waiting line. And then they'll move on to simulation with 2 ATMs, and that's when we'll be looking at Hammond's port 2. But I'm going to go back here for a moment, okay? And I want to make sure that you're not confused about what you're seeing, especially here in the simulation. We're simulating 1,000 customers. Their inter-arrival times, their arrival times, the service start time, the waiting time, and we go up to 5, and then they hide the rest of them. So don't let that confuse you. Let's look at the inter-arrival time, and notice what we've done here. This equals B4, okay, plus some random number times B5 minus B4. Now let's go back up here for just a moment. Let's look at B5, pardon me, B4 is the smallest value, and that's 0. And then we have some random number added to it, and that's times B5, which is the largest value, minus B4. So we're basically, we're basically start building our point where we're going to build, we're going to get a sum of differences. And we can see this, and here we come across, here's the arrival time. The inter-arrival time, excuse me. Here's the arrival time. Here's the service start time, waiting time. Here's the service time, you can see. And here, and then here you see we use the norm inverse of that random number. And then we get the completion time, and then we get the time in this system. Now, we get those summary data, and the probability of waiting less than a minute. And so we've used these. Okay? Now, and so that's what we needed to do in Hammond's port in the key. Now I'm going to close this, okay? And I'm going to go back into Canvas, all right? And I'm going to go back here because I have screenshots for you, okay, so that you can see. Here's find this back up here. Excuse me. I thought I had you a screenshot for that one. Well, we didn't, but we did see how we got it. Okay, and I have a Zoom recording on it, but let's look at it again. All right, now again, we're up here, and I had given you a second task, so we'll download the file again. And I thought I had it in a screencast. I was just going to show you. All right, but we won't do that. We'll download it. Okay, we'll enable the editing part. And the second part of this is use the goal seek to discern the service cost per channel. Okay, and wait a minute, this is single arbitrary. I don't want that. I want Hammond's port. Well, I showed you Hammond's port 1 and working on it. I think I just showed you single arbitrary. I apologize. I'm pretty sure I showed you. Yeah. Let's take a look here. Wow. I'm kind of like out of it today. Yeah, this is single arbitrary. I apologize. But you can take a look there. We've been here. Now, here's single arbitrary. We're asking you as a goal seek to obtain the service cost per channel and assume the waiting cost per unit is $1.16. Okay, so here's the solution for it. We have a waiting cost of $1.16, and we get the service cost per channel, and we assume that the total cost per period is $2.99. So we do the economic analysis there for that case. Okay. Now, well, let's go back here again, because I want to talk about this for a moment. We're dealing with what we call arbitrary service times. This, of course, is a single model. And so it's a little bit different from Hammond's port. And I'm going to go back to the Hammond's port and spend a little bit more time on it. Okay, so we'll pop over there. And this is where to upload it. And I give you, again, the second thing I ask you to do on Hammond's, that's due the 13th, is to use goal seek to obtain a maximum waiting time to 9.5 by changing the mean service time. Okay? As I tell you, it's over on page 567. You'll need to review the pages 561 to 72 because they cover this issue of simulation. Okay? And it's due on the 13th. And I have the Hammond's port key down here, all right, which I showed you. And then I'm going to make this unpublished again. And then here's the Hammond's port key screenshot, which I'm going to publish for just a moment. And I'll let you see. And I have a video on Hammond's port 1 as well. Now I'm going to download it here for a second. I will be able to see it a little bit better. And I'm going to take that and do this with it. I'm going to try to pop it up a little bit more. probably by changing the largest value. We did that. And the second was to change the maximum waiting time, okay, to 9.5 by changing the mean service time. That's part B, okay? And it's just a matter of using the goal seek and handling those variables. So we're saying that we can, here's what's happening with Hammond's port. And as you work through it, we'll go back over here. Okay. In Hammond's port, we're doing two things. First of all, we're simulating arrival times. Okay. Secondly, we're using the goal seek to change the key variables to see what the operating characteristics look like. In other words, the distribution, what they look like. And if we go back over here, we'll see they show us a histogram, and they have 900 customers. Then we'll see a Hammond's port 2 when we start to look at a 2 ATM system. So we go from that 1 ATM, okay, with that very simplistic model. And here's the worksheet as the authors walk us through it. And here again, the authors want to make sure that we see how this unfolds, so they see each customer and how we computed that. And then they show us the totals over in table 10, 12. And we'll go back here. And there's the model. And again, that's what we're doing. Now, we built the flow chart, which is, again, the iconic model of flow chart. That's what it is. All right. Then the second thing we did was we went ahead and built a mathematical model. And we come up with the simulation results. And they did 10 ATM customers. And here's let's look at customer number 1. The arrival time is 1.4. Then the arrival time is 1.4. They start their service time at 1.4. Then they have no waiting time. This is the first person that came in there. There's no wait. It takes 2.3 minutes to serve them. So their completion time is 3.7. It's the service start time, okay, plus the completion time, and that gives us then the time in the system. And it just is iteration after iteration, and then we compute the totals and the averages. And that's what we're doing there. And they just walk us through the math of doing it. So that's Hammond's port, okay? Now, the other thing that I wanted to talk about today, and as I'd said before, I'm going to go over 50 minutes, is, and now I have a key for single arbitrary, which was due last week, and you have a link to a Zoom recording dealing with that, so you'll want to take a look at it. Is I have Support Center 1 and Support Center 2. Those deal with that outliers case, okay, in Chapter 13. That's Support Center XLSX. So let's go over to the files. Okay, and we're going to go down to the Foreman files. There's a zip code. I'll download those. All right, and we'll open it. And we're going to go over to chapter 9, I believe, is the chapter that's in that text. Yeah, here's Support Center. And I'm going to diminish my browser. I'm going to put Support Center out here on my desktop. And I'll copy and replace it. Okay. I'm going to open it up because you will be needing to upload it for credit for the workshop. And it's taking a bit of time to open up for us today. And there we are. Now, in the Support Center documents, I walk you through basically what's in each one. Now we're going to start with this, all right? And here's the Support Personnel tab. That's pretty self-explanatory. Now, again, over in chapter 9, we have that textbook. Okay. Now, I want to say at this juncture, as you can see, if you view the recording, which I hope you do sincerely, I'm a little concerned I don't have anybody here, but you know, it's a remote broadcast. And so if you chose, and I've given you that freedom, chose not to be here or not here. We're in the Support Personnel again. Remember, we have the employee ID, number of average tickets they do per day, customer rating, are they tardy, graveyard shifts. These are variables or dimensions that we believe are important in terms of this person's of gauging their overall performance. And you can see with the sick days taken, weekend shifts, graveyard shifts, shift swaps, there's a sense here that these folks, the climate or the camaraderie of them, okay, is dependent upon the extent to which they work together. And then we get some summary data. So far, no big deal. Now we're going to go over to the standardized, all right, the employee ID tab, but the average daily tickets. Here we've used the standardized function in Excel. And we choose a value. Then we choose the mean and the standard deviation, and that gives us a standardized score. So what we've done is we've cleaned these data up a little bit. We've did a little data wrangling, and we've cleaned them up in order to be able to compare everybody. All right, and we do the same thing with the customer ratings. Okay. Now notice that we're pulling data from the Support Personnel worksheet. So we're using cell referencing, and so when you see that Support Personnel and then an exclamation point and then a cell reference, that means we're going back to that tab. And we do this for tardies taken, graveyard shifts, the whole bit. So we standardize the data so we can compare them. Now, note that because when we use a standard deviation, okay, we should end up with a 0 because standard deviations end up when they're added to 0. And so this is over in the Support Personnel tab. You're going to see that explanation about the standardized tab. We'll go all the way down to the bottom. And if we add them, we would get 0. Now we're going to move into the distances tab. Now what we're going to do here is we're going to compute the distance between employees. Now here's employee ID. Well, here's employee 144624, and they're compared to themselves. And this is where things do start to get a little bit complicated. All right. And again, I've got 2 PDFs there for you, which you can look to see detailed explanations of what's going on here. Okay. Now in this distances tab, we're going to get the square root of the sum of a set of numbers, of standardized numbers, okay, squared. You can see there's the, I'll click the FF so you can see it. And you'll see a thing in there, the offset function. And I explain that there. The offset tells us the anchor cell, the number of rows, okay, and the number of columns. So we get the width and the depth. For example, in C number 3, we're going to draw from the standardized worksheet, okay, and we're going to get cell B2 through K2. Those will be our rows. And A3 refers back to A3 in the distances tab. It's 0. And we're going to have a 0 columns to the left. And that 0 means 0 columns to the left or the right. That's what the 0 is up here. Pardon me, that's in cell C3. And so we're computing distances. And he said this looks suspiciously like what we did earlier with our first case. You're indeed correct. Now, over in the I think it's either the support center PDF, either 1 or 2. I can't remember. I walk you through. I show you a shot or a picture of some employees and comparing them and using the Euclidean distance. Okay? And that's what we're doing. We're looking for outliers. So like in cluster analysis, we look for how things clump together. Here we're looking for things, how they are outliers. Okay? Now we're going to come down here to the rank and we'll do some ranking. The rank tab function, and we're using that function. Now I'll click on it here for you. And the rank is 252. I'll click OK. And the rank function operates like this. Okay? We're using the data from the distances tab. And we're using NG3. That's the reference. And then I have a reference to, okay, an array of some type of list of numbers, and then an order. And if it's 0, it's omitted. If we have a non-zero value, it creates an ascending order rank. And we use a correction here, that's the -1, to deal with ties. So we're able to rank everybody. And in those PDFs, I walk you through, the rank says it's its size relative to everybody else it's compared with. Then we get the K distance. You say, oh, this sounds very familiar. Yeah. And the K distance tab. And I'll also say this over in the support center documents, I again walk you through that whole notion of distance and clusters and how that all works. And it's using that Euclidean distance. Okay. And then the K distance is tab, we start with the employee ID. and we compute their K distance, we get the sum of their ranks times their distances. And that's how we get a distance. Now we do this assuming that there are five employees in your neighborhood. So we say, okay, we're going to start with 5. That's why you see the B1 all right, we're in the rank and we take the sum if we sum it if we get that distance as time the distances times distances, and that's how we get. Basically what it's saying is this: we're going to take everybody's distance to their 5th nearest closest neighbor, assuming that if you're an outlier, you're going to be close to another neighborhood. So we're going to take the sum, which is self-explanatory. We're going to use the if statement. We're doing a conditional format. The rank, that's B2 to OK2. That's the range being checked. And then B1 is our criteria, and that's 5. And then 1, we set the value to 1 in a vector of zeros. And then we have a 0 times distances, and that distance is, of course, over there in the distances tab. And we look at that array of C3 to OL3. And I give you a detailed walkthrough of this. So we're getting a sense of, okay, how far are they? Then finally, we're going to do the reach. Okay. And in the text, in chapter 9, he walks you through tab by tab by tab. Now, in that distances tab, we were using a gradient. Okay. And over here in this reach distance, notice that we're using a maximum. And it's maximum of B1. Okay. That was the K distance for that first person. And then the distance is 3. And that's that's back for the distance is 3. The row 1 is the transposed values from the K distance, basically B4, it's the formula. And we do this for all employee IDs. Okay? So we're computing their distance, how close they are to their nearest neighbors. Because the greater that number, the greater we have an outlier. Then we just simply take that average reachability distance, and we come up with a local outlier factor. And we apply conditional formatting. And of course, those with the higher factors are those who are people that we want to take a look at. And they use the conditional format, for anybody over a local outlier factor value. Now, I'm not going to pretend to sit here and tell you that, this is something easy just to put together. It's not. It's pretty sophisticated. And part of it is part of what can confuse you is he's doing cell references to different tabs. Okay. He's using some more database type options, like the offset, okay, which can kind of confuse us. But just says here's the corner of the array, here's how far I go across, here's how deep I go, or how many rows I go, excuse me. So how many columns I go across, how many rows I go down. Then we normalize. Then we have normalized data. We use that. We use the ranking function, and we find out. And here, of course, is that over the K distance. Again, we're using that Euclidean model, but this time we're looking to see how close we are to our nearest neighbors. So those are the outliers, okay? Think of it like you'd see a regression line, okay? And you'd be looking at that regression line, all right? And you'd have data points clustering it, and then some outliers. So that's the outlier. That's the outliers problem that we had to work with, and we won't save that. Okay, we'll go back up here, and we'll go back over to today. Excuse me, 411. Okay, so we've talked about single arbitrary, and again, if you want to see it in action, just done live, there's a link. Here are Support Center 1 and Support Center 2. These are PDFs that explain that process, and you can dig into it along with as he walks you through the text tab by tab. Now finally, okay, when we have z-scores, we know that z-scores, okay, standardized scores, represent an assumed probability distribution, okay? And we assume that a z-score, tells us where some observation is along the curve. So I provided you, okay, a z-score calculator. And go out over there, and you can put in the z-score, and you can put the significance level. And we've talked about that before. This is the alpha level. Then are we taking a one-tailed or two-tailed hypothesis? You should remember from stat, if I'm doing a two-tailed hypothesis, I'm looking at everything from the mean to the right, headed up, or and then everything from the mean to the left. Or if I'm looking at a one-tailed, and I can calculate my z-score. And so I have that resource there for you. Again, here's the chapter 11 exam, and some more information on how important queuing theory is. And again, we looked at Hammond's port 1, which is 1 ATM next week, and you'll have Hammond's port 2 for next week. All right. Well, folks, that pretty much does it. I've gone 50 minutes plus about 5 or 10 minutes extra, so I've gone about an hour, a little bit extra. And again, the work that you have to upload to get it done, and we've talked about what's coming ahead of us. Okay, as we move into that flex time part. And so I'm going to stop the meeting, and then I'll save it and post it for you.